difficult to recycle waste streams. So as an example, what the challenge is, composite materials in general, like electronic waste or printed circuit boards, shredder residues from the automotive sector, but also glass and fiber reinforced plastics, as you find it in airplanes or in rotor blades. These waste streams are very hard to recycle mechanically, and the amount of these plastic waste is increasing significant over the last years. That's why we need an innovative solution for these waste streams, and we developed the so-called iCycle technology, which is a platform technology for the recycling of composite materials. So just a schematic picture how the technology works. You can feed the system with different kind of waste, like for example, electronic waste, reinforced plastics, but also waste plastics in general. And via a chamber system, it is possible to feed the so-called Auger reactor. This is a screw reactor. And via this chamber system, the atmosphere is exchanged from air into an inertized nitrogen atmosphere. The whole system is heated up to around 600, 650 degrees. And at this temperature, it is possible to separate all the inorganic material from the organic material. So in the end, you end up with a so-called char metal mixture, where you find the inorganics free from organic material. And the organic material, based on the plastics, can be condensed as an oil or can be found as gas. The gas itself can be used for energy recovery to provide heat for the whole system, and the oil can be used for chemical recycling. You find very valuable chemicals in this oil, which can be reused for the production of new polymers. So as an example, recycling of glass fiber reinforced plastics is depicted here. So we did it with shredded rotor blades. And with iCycle, it was possible to get a pyrolysis oil, which upon distillation and purification of the pyrolysis oil, it was possible to get pure phenols, which is a basic chemical for the production of epoxide plastics, but also chemicals like benzene, toluene, and styrene were possible to isolate. And out of these chemicals, it is possible to make virgin grade polymers again. On the other side, we end up with solid residues. For example, in this case, it was char and fibers. And with physical separations technologies like sieving, flotation, or density separation, it is possible to isolate glass fibers or carbon fibers, which could be used for a foaming process to produce foam glass. So the benefits, iCycle as a platform technology is applicable for a very broad range of waste types. We have a patented Auger reactor for premium product quality. It is possible to recover precious metals, fibers, gas, oil, or chemicals, and no catalyst is required within these technologies. The desired types of cooperation could be, for example, feasibility studies for application in Israel. We can do test trials with several input material and demonstration projects. It's possible to integrate the technology in existing recycling infrastructure. And what we also can offer is training, know-how transfer, and license agreements. So this was the first part. I will just start with the next presentation. I need just a second. Yeah. So you see the other slide?
Yes, we can see it.
Thank you. So the next topic will be about the recycling of mineral waste and the removal of organic contaminants. So the challenge here is to remove tar and oil from minerals. So input material here, the focus could be, for example, oil, contaminated soil, or contaminated minerals, but also mixed mineral waste from construction site, contaminated mining waste, or tar-containing road construction waste. So for this input material, we need we developed a thermochemical treatment and decontamination technology. The advantage here is that we can do a gentle treatment, and under these conditions, the mechanical stability of the minerals can be kept. So what is very important, for example, with asphaltos, it's necessary to do the process in temperatures below 550 degrees, as at this temperature, the so-called quartz inversion starts and the quality of the material decrease. That's why we do our process at temperatures between 200 and 550 degrees. But what is necessary to remove all the oil contamination is then to also do the process under reduced pressure, up to 500 millibar. And what can also be used is a cracking agent as well, for example, air, oxygen, or water. And under these conditions, it is possible to keep the mechanical stability. The separated oil can be used for energy recovery and to provide energy for the process heat. So in this slide, we depicted some results. In Germany, for example, so for tar-contaminated asphaltos, there is a law that it is necessary to be under 25 milligrams per kilograms of polycyclic aromatic hydrocarbons. The starting material, however, is far away from this value. It is around 2000 milligrams per kilogram. And with state-of-the-art pyrolysis, it is possible only to decrease this up to 1,500 milligram per kilogram. So it's not possible with state-of-the-art pyrolysis to get under the limitation of 25 milligrams per kilo. With the innovative approach, so with low pressure as well as a cracking reagent, we achieved the decrease of the polycyclic aromatic hydrogen content up to 7.4 and even less milligram per kilograms. But what is also important is the quality of the material, and this is depicted here. So we measured the resistance against fragmentation, and this is measured by the so-called Los Angeles coefficient. And for general recycling material, we have a coefficient about 30%. So this is not the value that you find in virgin quality, like for example, basalt, which has a very high quality and a high resistance against fragmentation. And with our process, it is possible to achieve these values. So we have 12.8%, which is in the area of basalt, so very high quality. So in the end, the benefits, we have a safe and complete decontamination of mineral waste. It is a very robust and simple plant and process technology. It is possible to get high quality recyclables. And also a decentralized approach is possible. So we have low logistic efforts. And here also we can imagine to do feasibility studies for application in Israel. We can do test trials and adapt specific needs of the Israeli companies, and also scale up projects and integration in existing recycling infrastructure is possible, as well as license agreements with manufacturers and operators. So thank you very much for your attention, and feel free later to ask questions.
Very much. Just a reminder for the presenters, we have 6 minutes for each presentation. Okay, now we'll move to the next presenter. This is Mr. Frank Holm-Rogner. Are you here?
Yes. Hi, everyone.
You will present representation, right?
Yep, it's right.
Okay, so please, thank you.
Yeah, I'm starting the first one. So you can see it?
Yes, we can see it.
Okay, perfect. So I'm head of the cleaning business area of Fraunhofer. So I represent a lot of institutes dealing in the cleaning area. First one I want to the first one I want to talk about is electron treatment of wastewater. It's a technology to clean up wastewater in an additional step. The first question is why? We have an environmental pollution by wastewater because of an increasing concentration of persistent pharmaceuticals, cosmetics, detergents, hormones, medical agents, viruses, and so on and so on. And we see also an increasing concentration of PFAS in water and groundwater and wastewater. And we have no possibility to remove it from waste because it's very, very low concentration, but high effect to humans. And we have a critical concentration. We have mineral oil products in water and also diet. That's why worldwide we have some efforts to purify wastewater in a fourth step of cleaning, so-called micro-purification. And there are a lot of trials, industrial trials to use it by, for instance, ozonization. It's effective, of course, but you need a post-treatment of the decomposed products. There is a membrane separation available, but it's very expensive because you need a very large area of membrane to have a throughput high enough for wastewater treatment. And you produce high concentrated toxic filtrates. There is a possibility to absorb by active charcoal. It's also effective, but it's you have a high disposal cost. And the first version we prefer is an ionizing irradiation of the wastewater with an additional biological post-treatment step. It's very effective and efficient. We have a broadband efficiency, but that's a disadvantage. We have high investment cost by the irradiation machine. Nevertheless, there are some industrial pilot trials worldwide, also by our international partners. On the left side, you have an example for it. It's an electron irradiation machine for wastewater for 10,000 cubic meters per day in an industrial wastewater plant by an irradiation dose of 2 kilograms. The electron beam machine itself has a power of an energy, an irradiation energy of 1 mega electron volt. It's the acceleration of electrons and the necessary power of 400 kilowatts. We have partners for such powerful electron accelerators available for us, and we have some existing partner networks within an European project called ARIES. It's an accelerator community network, and also by the International Atomic Energy Agency, we have an existing network available for worldwide radiation chemistry analysis and also for accelerators. And we we are an institute to building up prototypes in case of electron beam machines. Such results are available for a TRL level of 6 to 7, I think. And we have an experience to build up machines, pilot machines, for instance. What are possible types of cooperation? It's feasibility study to real case scenario. It means a real wastewater treatment plant. We can adapt this technology to a special wastewater composition because it depends a little bit what are the special or high concentrated contaminants in the wastewater. To adapt the technology, of course, we can upscale the technology to a real case scenario, to a real throughput, for instance. We can make profitability analysis and also develop and manufacture prototype. That's the first one I could show you. So I want to share the next one. The next one is, excuse me. So you can see it?
Yes.
Okay, the next topic is energy, electron inactivation of biohazards in liquids. The special topic is using low energy electrons, and I want to explain why. There are two main topics for inactivation of biohazards in liquids. First one is for vaccine production. It's now an worldwide topic, of course, for vaccine development. But why? For vaccine production, typically the viruses, if you have no an RNA vaccine, but a commercial vaccine, they use viruses. But before a real vaccine exists, the virus have to be inactivated. Don't affect the humans. Typically, it's made by chemical agents like formaldehyde. It's very toxic and have to be removed with an enormous effort during production. It takes a long time. Formaldehyde reduces the quality of the vaccine by their effects, and it's difficult to reproduce such a chemical inactivation. On the other hand, a lot of pharmaceutical waste exists and it has to be inactivated. Typically, it's done by thermal inactivation, and it's very energy consuming. You imagine, I think, and it needs an expensive logistic because of the high toxic hazard, and it can't be integrated into the production. That's why there is an idea, or there was an idea, to use ionizing irradiation in case of low energy electrons to inactivate it, because it's very effective. It could be done inline in the production. It don't need a high shielding effort against irradiation, and it takes only seconds or milliseconds to inactivate. Therefore, we developed this in a Fraunhofer internal project with Fraunhofer partners, and also by partly funding by Bill and Melinda Gates Foundation. We developed a prototype machine for an inline inactivation of biohazard containing liquid. The example here was for vaccine production, low throughput, it's liters per hour, but high contaminated liquids. The technology is patented, it's in Fraunhofer, and also in this case, our institute has a long-term experience in development and manufacturing of pilot machines for industrial use. Also here, possible types of cooperation is feasibility study to a special biohazard containing in a liquid, or as a technological adaptation to a special production chain within a pharmaceutical production, maybe for vaccines, or upscaling for a higher throughput to in the range of 100 liters per hour, and also development and manufacturing of prototype equipment for industrial use, of course, or licensing of the technology. It was the second one, and I show you now the third. Excuse me. Can you see the third one?
Yeah, we can see it.
Perfect. The third topic is not based on water, it's electron treatment of diesel exhaust gases. It's an environmental problem or environmental topic we are dealing with, although interesting for worldwide application. What's the background? We have in huge environmental pollution by large diesel engines because they are fired with heavy fuels. And we can see by a lot of studies, it's a dramatically effect to humans in areas surrounding harbors or coasts, and it's dramatically. We have not only an NOx emission, it's at the same time an SO2 or SOx emission due to the high sulfur content of within the heavy fuel. And there's actually no economically available solution to remove it simultaneously. There are solutions to remove NOx and SOx, but it's have to be done step by step, and it's you have a lot of effort. You produce a lot of difficult ways that is actually solutions. Of course, there are new regulations, and they will reduce sulfur content in fuel in the future also actually, but there are a lot of existing machines that can't be fired with a low sulfur content fuel. And though we have an existing problems with a lot of existing and running diesel engines with a high pollution potential. You know, we are electron beam experts, and so we use also here electron beam irradiation, and we could show it at a real harbor place with a diesel engine of a smaller ship, but a real diesel engine fired with heavy fuel. And what is done? The flue gas of the diesel engine is irradiated by electrons. These low energy electrons should penetrate the tube, of course, and the gas inside. We can enhance the effect by inlet of urea, liquid urea. It helps for the radiation chemistry inside, and at the end we need an seawater scrubber to remove the reaction products from the outlet gas. And with this technology, it's possible to remove simultaneously NOx and SOx dramatically in the range of 70 to 90%. And it helps to upgrade old large diesel engines also in a ship, in a real ship environment, to clean the flue gas dramatically. We could show it with a mobile machine. See it in the bottom right. It's original machine for electron treatment of seed to disinfect. We have adapted to treat flue gas and could show it in a demonstration test in a Riga shipyard in Latvia to remove also such contaminations from outlet gas. We could show the technological function, of course, can demonstrate it under real conditions. And the technology is now ready to upscale. Of course, it was a low throughput, it was a short-term demonstration, but we could generate a lot of or enough results to upscale it. And we have some partners involved in this technology. It's a Polish institute and a Riga Technology University, also some companies in Poland and Riga. And we could get for such development co-funding from the EU project areas. And therewith we could gap we could close the gap between the ship and accelerator community to understand the need of both and could show it works also under real conditions by our mobile accelerator. That's a low TRL level because it's a demonstration experiment, but it's really understand and ready to upscale. Though we are available for a feasibility study for a real case scenario, real flue gas, as well as from on ships or on stationary power plants using oil, and we can upscale it and development also in prototype equipment as well. So that's all from me.
Thank you very much. Now we'll move to the next presentation. Will be presented by Dr. Anthony Dalebard.
Yes, hello, my name is Julius Potika. I'm presenting for my colleague, Dr. Dalibard, because he's doing another presentation in another room.
Okay,
I will start my presentation. So, can you see the slides?
Yes, we can see it.
Okay, great. So my name is Julius Potika. I'm a scientist at the Fraunhofer Institute for Interfacial Engineering and Biotechnology in Stuttgart. And alongside my colleague, Dr. Antoine Dalibard, we are working on the topic of water production from air humidity by the use of sorption process, mainly for the use in arid regions where you don't have access to any other water sources. So you need some other sources to produce your water. First of all, I want to start by introducing the process principle of the air water harvesting process. We start with a highly concentrated hygroscopic salt solution, such as, for example, lithium chloride. And this salt solution is then brought into contact with the humid air, and by the means of absorption, absorbs the air humidity to then become diluted. This diluted salt solution is then distillated and thus becoming, again, highly concentrated to use in a cyclic process, and of course as well produce the product, the condensate, which will then result in drinking water. I want to show you our already built prototype for this project, which you can see here on the right. This demonstration plant was designed and built using a 40-foot and two 20-foot containers. The 40-foot container is planted upright here in the middle and contains both the desorption unit as well as two absorption chambers. In the 20-foot containers on the left and on the right on the bottom, on the left side there's a techniques and control. And on the right side, we have the salt solution storage. This plant works as such that from the salt solution storage, the salt solution is pumped up the tower, firstly into the desorption unit, where by the use of a multi-stage vacuum evaporation unit, the salt solution, as I mentioned before, becomes concentrated and we produce the water. Then the salt solution flows gravimetrically from the desorption unit down to the 2 absorption chambers, which are filled with loose packing to maximize the mass transfer area for the absorption process. By the use of fans, you can see here at the bottom of both absorption chambers, air is directed upwards in those absorption chambers for a countercurrent flow, and then of course the absorption in those chambers. After the absorption, the diluted solution then again flows to the salt solution storage. By the use of these containers, the 40-foot and the 2 20-foot containers, the whole plant becomes easily transportable for use in remote regions. You can see on the left side here, we also have a photovoltaic system, which allows for standalone operation using renewable energies. This standalone operation is possible due to the use of low temperature heat supply for the desorption process using the solar thermal technology, because the heat needed for the desorption process is below 100 degrees Celsius. And again, as I mentioned, the power supply can be done by the use of solar photovoltaic systems, or also, if the conditions allow for it, maybe a wind turbine for the operation of the peripheral devices, such as the control unit, the valves, the pumps, and so on. Lastly, I want to talk about the commercialization aspect of this technology. This technology is already licensed to an industrial partner we are working with. And right now we are developing with that industrial partner a much larger absorption column to maximize water production and economical feasibility. And our partner would prefer to run these units in a contracting model, including the financing of the investment, which would then result in the water being sold per cubic meter for a set price. There are multiple types of plant designs possible, including the system integration of this technology. As I mentioned before, a decentralized standalone operation using renewable energies is possible, but as well a much more scalable plant with many absorption columns. You can see the schematic here on the bottom right, and a separated desorption unit would be possible for the much more scalability and much higher production of water and a larger economic feasibility. Yeah, thanks for your attention. And if you have any questions, we'll be happy to answer them via email or shortly after in the question round.
Okay, thank you very much. Dr. Divas, are you here?
I'm here.
You want to present your presentation?
Yeah, let me do it. I don't know if you can share my presentation. It's much better.
Yeah. I'll try just a minute. You can see the presentation?
Thank you. I can see it, yes.
Okay, please.
So I can start. My name is Divas Kalmanzira from the Institute of Optronics and System Technique in Elmenau. And I'm the Vice Group Leader of the Department of Surface Water and the Maritime Systems. As you can see from the name, we concentrate and mainly research on optimization of water systems, but we also develop underwater vehicles like ROVs and AUVs for different purposes. And we have sold quite a number of vehicles already under different licensing models in China, Canada, and so on, and also in Germany. So the technology which I'm going to introduce here is an underwater vehicle which can be used for different purposes. For example, reservoir monitoring, dam inspection, and exploration tasks, and so on. Can you switch to the next slide? So in the next slide, I will show some properties of the underwater vehicle. You can see the underwater vehicle has got a flexible design in that you can put several payloads types which you want to use. For example, forward-looking sonars, you can put laser scanners, you can put water quality monitoring sensors, even water samplers. We got some prototypes there. And also, it is very highly flexible that you can use it as a ROV, that means remotely operated, or you can use it as a fully autonomous AUV. And as a ROV, you can see it's still flexible because it's got an internal battery. And with the internal battery, we just need a thin fiber cable for connecting it to the control station. So you can maneuver it around the way you want. And also, it comes with standard sensors for navigation. It's got GPS, pressure sensors, and you can also see cameras are also in the standard program. And with the cameras, we've got special software which you can use, to put some subtitles, for visual capturing, so like sensor information at that moment, geolocations, date, and so on. And there are some optional sensors which you can provide, and also from our partners, like forward-looking sonars, water quality sensors, water samplers, and for measuring depth, and for bathymetry, you can use altimeters, for example, and also for precision of navigation, you can also get some USBL modems. So, as I said, this AUV can be used in, for example, inspection. So it is really highly maneuverable. That means it can turn on the spot, and that's very important. For example, if you are doing dam inspections, for example, that you can have a vertical thruster which can drive the vehicle down to a certain depth, at a certain position, in the XY axis, for example. And also the battery is easily changeable, so that you can change the battery anytime you want during a mission. And then another advantage is that this AUV, you can see, is small. It's only about 50 by 1 meter, and it can be easily carried by 2 people. It's enough. And also the software, as I mentioned before, is very user-friendly, and also it goes interfaces which can be extended easily, and also the sensors are locked in normal, also standard data formats which you can analyze in Excel, MATLAB, and so on. And as I said before, this AUV, we can use it for different purposes. So we sold already, we have got some license agreement with different companies, like in China, for example, the China Agriculture University, they do, for example, observation in coral reefs for quality, see how the fish are living there, or in their reservoirs, big reservoirs, like Mune Reservoir, they do, for example, water sampling or go around the reservoir, take 3D water quality and make a picture of it and see really how the reservoir is. Yeah, and we, not only in China, we saw this AUV already. We got also some cooperation with the Canada company. Yeah, and in that way, we can cooperate with any company in Israel also if there are some needs. Yeah. Yeah. Thank you very much. You can go to the next slide for my email. Thank you very much, everyone, for waiting.
Thank you very much. Now we have a few minutes. If someone wants to ask any questions, feel free. In any case, we will circulate all the materials, all the presentations, and the details of the participant. Okay, so if there is no questions, thank you very much for joining us.
Thank you also from me. And
thank you very much.
Yeah.
Thank you.
Bye.
Thank you.
This is all?
Yeah, this is all the presentations. We will send you everything to your email.
Okay, thank you very much. Send it, please.
Thank you.
Bye-bye.
Bye-bye.